Hello everyone, welcome to May This Bridge. How are you all doing? I hope you are all doing great. Thanks for joining. In today's session, we shall continue our machine learning, basic building blocks understanding. We are going to drill down more into supervised learning by exploring the few of the use cases. Without further delay, let's get started. Quote for the day: predicting the future is not magic. It's artificial intelligence, said by Dave Waters. In today's agenda, we shall explore some of the use cases in supervised learning. For more learning videos, please do visit us at our YouTube channel at Maths Bridge. Okay, please do subscribe the channel if you are yet to be. Thanks for all your support. Let's have a closer look at a process flow of a supervised learning. We have the few steps: data collection, data processing, splitting the data into training data and test data, choosing the model, train the model, evaluating the model, then make the predictions using that trained model. These are the 7 steps that we use in supervised learning. Machine learning. We know that the data set is a important input for us. So all you require is like the processor data set. And if you have the processor data set, what you would do is you split the data set into two parts, like a training data and a testing data. In thumb rule, 80% of the data set can be considered as a training data. Remaining 20% can be used for the testing the model, so testing data. So let's take a training data and testing data and then do this process. So we have a training, means train the model, validate the model, and predict using that trained model. These are the 3 phases that you can see in supervised learning. Alright, so assuming that you have chosen an algorithm based on the problem that is given versus the outcome that you are going to predict. So you are now train the algorithm, train the model, create the model, and then build the model. Is also known as a train the model. You are training the model using training data. Assume that you train the model. Now you are going to test the model using the remaining test data in validation phase. So when you test the model in the validation phase, that is going to predict label data, right, as an outcome. You just monitoring whether it is really predicting accurately as you wish to see, isn't it? If you are able to see the prediction is kind of like in a sense to you, then what you have to do, you all together use this that trained model to predict a new data set given to it. Is called a prediction base. So this is how the entire process works in supervised learning. I hope you could realize how your learning process inside your brain. Predicting house price using supervised learning. We will see how supervised learning is going to use for predicting housing prices. Predicting house price using supervised learning. We know this there are the 7 steps that are being used for the predicting the price using supervised learning, right? So what is the first step? First step is like a data collection, meaning gathering historical data on house price along with their features. When you say that, like a number of bedrooms, square footage, location, age of house, number of bathrooms, lot size, proximity to schools, the sales price, the target variable value, things like that. This is a sort of the data that you are going to collect it, but making sure you have a accurate data, otherwise your productions may go, you know, wrong. So the second step is going to process the data to get the accurate, like handling missing values, encoding categorical variables, and features scaling, things like that. Once you have the processor data, now what we have to do, you have to splitting the data into 80/20 rule for both training data and testing data. In the fourth step, we have to choose the model. This is the vital, the player. This step is basically help you to identify your problem scenario and then try to figure out what you are trying to find out as part of your the prediction, and then choose the appropriate model. In our case, the predicting the price value is a continuous value, and hence we have to use a statistical model is known as regression algorithm. Precisely, we are going to use a linear regression algorithm in this case. Okay, linear regression plays, what we have to do is like it takes the all data pointers from the data set, the process data set, and trying to fit into line of regression curve. You may have like a lot of deviation from each point to the line of regression, so you have to adjust to get a minimum error so that your prediction can be more accurate value. So this exercise, what we can call it as, you train the model. So fit the linear regression model on the training data is known as training the model. Once you have the model being trained, then you have to evaluating the model. So in the regression, linear regression, what you have to have is some constants within the regression. So those are called tuning parameters. Using your test process, meaning test the model on testing dataset and evaluate it performance using metrics such as mean squared error or r squared error, are the two parametric pointers which we have to tune so that it is going to be predict given label data accurately. So once you have evaluate the model and then you are gain the confidence from that model, then what you have to do, use that same model to predict by showing it new data. Use the trained model to predict the house price of new data. So this process of supervised learning, right, easily illustrated in this example. Supervised learning problem involving regression to predict house prices based on historical data. Email spam classification. Okay, this use case is part of your supervised learning. We studied, right, in supervised learning we given input and annotation to the input, meaning a labeled input. That means like we know what should be the output. So we trained in a model such that it is going to understand what that input is and classify them accordingly. The spam detector is supervised learning based machine learning algorithm, which is a intelligence to classify given input emails and put them in right placeholder. For instance, here we have a inbox is a placeholder for the good emails, and then spam placeholder for the spam emails. So as and when it sees an email, it is now able to classify the emails and route them to the respective placeholder. That is a sort of like an use case that we use supervised learning to classify spam classification emails. Now let's look at all detailed process flow steps which we use in supervised learning for classifying email whether it is a spam or not. So you remember all these steps: data collection, data processing, splitting data, choosing model, training the model, evaluating the model, make predictions. Let's look at each step in detail. In the data collection step, what we do, we gather the data set of emails. Each email labeled either spam or not spam, right? That is how you are actually collecting the data. So if you look at in detail, email content could be like a text, presence of certain keywords like a free, winner, money, things like that, and a sender's email address, and the number of links, number of attachments, output of the email labeled as a spam or not spam. These are the kind of you know uh, the column data, the data in detail is what we are supposed to actually collect them. These could be called as a even features or input attributes for for classifying the kind of a category, right? Once we have the data collected, then the next step would be data processing. It's again a general process. We have to like handle all the missing values, encoding the categorical variables, and then future scaling and all. This is a common step for all supervised learning algorithm activity. Once you have the data ready and a clean processed data, right, a qualitative data, which you believe that is going to help you to actually build your model. So having said that, now we are going to split the data into two parts. So we can call it as a training data and testing data. The rule that you are using like a 80% 20%. 80% of the given data set can be considered as a training data, and which we are going to use for building a model, and 20% of the data, the remaining data set, is will be used for testing that model. That is how you have a data ready for your next step. Now the question is choosing the model. How you are going to choose the model? Now you look at, you are actually doing a classification. So if you look at a statistical, the models, right? The one of the best approach that we have to use to do this job is Navi Bayes algorithm. So Navi Bayes is like a statistical model, okay, particularly very effective for the text classifications, for instance. So we choose the model. Now we know the model, and then we have the data. What we are going to do, we try fit the data, you know, uh, into this model. Is called as a training. Training the model. Training the model is a step in which we fit the Navi Bayes model on the training data. You clear? So once you have this done, the next step would be evaluating the model. So assuming that your training is done, but you try to see like how you are going to test it, right? So you try test the the model using your test data, which we split in the step number 3. So using that testing data, you are going to test it and then find out a performance metrics, how the model is actually really doing, in terms of like an accuracy and precision, recall, F1 score. These are the sort of a classification metrics which we use, for understanding like how model is really doing. Once you have a kind of a confidence that the model is giving a accurate, precise results, the then you consider that I think model is ready for the future predictions. What you would do now, you are going to get the new data altogether and like an unseen data, which we use as a input for this trained model, and then started doing predictions. So in the step number 7, make a predictions means use the trained model to classify new emails as either spam or not spam. That is a classification that you would expect to see from this model. So this is the one of the simple and best example, to understand the concept of supervised learning, right? This supervised learning problem involving classification to detect whether an email is spam based on its content. Next use case, predicting diabetes, which is again part of your supervised learning. Predicting diabetes, which is part of your supervised learning. As part of process flow of supervised learning, we have 7 steps: data collection, data processing, splitting the data, choosing model, training the model, evaluating the model, and then make the prediction. Data collection is a key and very important step for proceeding further steps. Here we are trying to predict whether the patient has diabetes or not. So you should collect the data with problem relevance. What that means is you have to gather the data set of a patient with the features related to diabetes diagnosis. Something like number of pregnancies, glucose level, blood pressure, skin thickness, insulin level, BMI, body mass index, diabetes pedigree function, something outcome like a 1 and 0. 1 if the patient has a diabetes, 0 if not. Once you have data collected, then what you have to do next step, data processing. Data processing basically handling missing values, encoding categorical variables if any, and feature scaling and things like that. This is again a general process for any data that you have considered for part of your problem solution. Once you have a process data ready, now what we have to do, we have to split the data using 80-20 rule. 80% of data can be considered as training data to train the model. 20% of the data can be used as a testing the model, like an evaluating the model. Okay, once you have this ready, now think of like what sort of model that we are going to use for this sort of problem solution. Definitely a classification or prediction, right? Select a classification algorithm. For example, let's use random forest classifier. So this is the algorithm which we can use for doing this job. Once you have the model ready, what we have to do, you have to fit the random forest model on the training data, 80% of input data. So once you train the model, next step is like you test the model. Test the model on testing dataset and evaluate its performance using metrics such as accuracy, precision, recall, and F1 score. Probably we will see these in detail in other session. Once the model is ready, and then when you have a confidence that your evaluation KPIs, key performance indicators, are giving best results, then model is kind of like ready for using predictions. So next thing, we have to use the same trained model to predict whether the given patient has diabetes or not, right? This is how you try to infer how you are going to build a machine learning algorithm to apply that business use case. So here in this case, supervised learning problem involves classification to predict whether the patient has diabetes based on their medical features. Supervised learning, customer churn prediction. Let's walk through this customer churn prediction use case through supervised learning process steps. In data collection, we are going to gather a data on customer behavior and demographics. Customer ID, age, gender, monthly spend, number of customer service calls, subscription plan, tenure, and final result. If the customer has churned, probably you choose like 1, otherwise 0. Once you have enough data collected on this problem domain, the next step would be data processing, handling missing values, encoding categorical variables, feature scaling. These things you will be doing in data processing. Once you cleaned up certain things to make good quality data, then what you have to do is like you are going to split the data into two sets: training data set and then testing data set using 80% 20% rule. Then you look at choosing the model. How you are going to choose the model, you would understand the what you are trying to achieve, right? So select the classification algorithm in this case, because you are going to classify, right? Because so what sort of algorithm, the model that you are going to use here, the best suit is like let's use a logistic regression. Once you have finalized the right model for this problem domain, then you train the model in means whatever the data that you have chosen as a training data, now you fit the logistic regression model on the training data. This is what mean by training the model. Once you train the model, now you test the model, right? So evaluating the model. So test the model on testing data set and evaluate its performance using metrics like an accuracy, precision, recall, F1 score, and etc. Once you done with like a step 6, assuming that now your model is trained fully, now you are going to use that model to make a predictions. So that is, you are going to do it in step 7, which is make a predictions. Use the trained model to predict whether new customers are likely to churn. So supervised learning problem involves classification to predict customer churn based on various features. I hope you are clear. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.